Before we go any further, here are some of the formulas you need to remember when dealing with conservative and non-conservative forces. I will have a detailed discussion of these when we talk about energy, but these can come in handy for this specific lecture only. First, in getting gravitational potential energy, you will use the formula PE sub gravity is equal to mgh, where m is mass, g is acceleration due to gravity, and h is height. For kinetic energy, we will use the formula 1/2 mv squared, where m is mass and v is velocity. And lastly, as mentioned in the previous video, we have mechanical energy, which can be computed using me is equal to ke plus pe. The unit that we will use in dealing with these energy quantities is joules. Now that we are somehow familiar with the basic formula in computing energy, let us have some of these problems. A boy dropped a 1 kilogram ball on the window 5 meters above the ground. What is the gravitational potential energy of the ball on the window? Let us again treat this using the scientific method of solving the problem. We identify first what is asked in the problem, which is the gravitational potential energy of the ball on the window before it drops. Next, the given values include mass of the ball, height of the dropping point, and the acceleration constant, 9.8 meters per second square. Because we are looking for potential energy, we will use the formula PE is equal to mgh. We will then substitute the values as follows. 1 multiplied by 9.81 meter per second square multiplied by 5 meters. We will simply perform the operation as it is, and the final answer would be 49.05 joules. Let us continue the previous example by adding this. A boy dropped a 1 kilogram ball on the window 5 meters above the ground. In this case, you need to find the kinetic energy of the ball upon hitting the ground. In this problem, you are asked to calculate for the kinetic energy of the ball upon hitting the ground. Remember that the potential energy of the ball on the highest point is the gravitational potential energy of the ball in the window. In this case, since velocity is not given, therefore, we cannot use 1/2 mv squared, right? We will use me is equal to pe plus ke equation. Let us analyze again the problem using this equation. Mechanical energy is equal to potential energy, which is the highest position, plus ke, which is the lowest position, where kinetic energy is equal to 0 since the ball is not moving when potential energy is in maximum, right? Then, total mechanical energy is equal to 49.05 joules, which we computed on example 1, plus 0 joule, and this is equal to 49.05 joules. Remember the principle of conservation of mechanical energy in last video? Here, the mechanical energy is conserved on any point of the drop. Therefore, since we are looking for the kinetic energy upon hitting the ground, which is the lowest point, we can imply that all the ball's potential energy is converted into kinetic energy upon hitting the ground. Thus we say, the highest potential energy is equal to the lowest kinetic energy. Therefore, since potential energy highest is equal to 49.05 joules, our kinetic energy lowest is equal to 49.05 joules. And this is the kinetic energy of the ball upon hitting the ground. Let us try to solve this last problem for this video. Still, this problem is related with the two previous problems. A boy dropped a 1 kilogram ball on the window 5 meters above the ground. Find the velocity of the ball upon hitting the ground. Again, we are asked to calculate the velocity of the ball upon hitting the ground. We can remember that the kinetic energy of the ball before hitting the ground is 49.05 joules, and the mass is 1 kilogram. I will pause this video and try to find the unknown variable. Okay, let us see. If you use KE is equal to 1/2 mv squared as your working equation, then you are on the right track. Next, we will substitute the values on this equation, which we can manipulate as V is equal to square root of 2KE over m. Let's substitute the values as follow, then solve as it is. The answer we will get is 9.90 meters per second. In the last part of this lesson for this week, we shall talk about power and how it is related with work. That is all for this video. I am Gilmar De Castro, and see you in the next video.